an acute angle. An acute angle is an angle that is less than 90 degrees. An obtuse angle is an angle that's greater than 90, but it's less than 180. A straight angle is 180 degrees. So this is a very, very important angle for you to remember, because a lot of times when we are trying to solve unknown information about a triangle or about angles, if you can remember that a straight line is 180 degrees, it will help you solve some of the unknowns pretty quick. And if this week's homework, you'll see that there's an advantage to having that information. And then reflex angle is an angle that's greater than 180 degrees but less than 360. So those angles we use consistently in geometry. Now you have the lesson plan from the last class that we had. So make sure when you're doing your homework that you look back at that lesson plan, because that will remind you of some of the basic things that you need to know, especially a description of the principles 1 through 5, because I'm not going to go through all those. But things that you want to remember besides the angles that we just refreshed on. Adjacent angles, what they are, so that's in that review sheet, that learning outcome sheet from 2 weeks ago or 3 weeks ago. Alternate interior angles, you want to make sure that you understand what those are. Corresponding angles, make sure you know what those are. And then the 5 principles. So with tonight's lesson plan and the one from 3 weeks ago, if you guys can call those both up when you're doing your assignment, it will help you quickly get through the questions that you need to get through. So tonight what we're going to talk about, as you probably saw with the what you saw with the lesson plan for tonight, we're going to talk about different triangles. As we go through these triangles, you know, it's funny that this used to be a lesson that we would try to get through pretty quickly, and then I very quickly realized that students weren't comprehending the important pieces, the important components of the triangles. It's not about learning the names and what they look like. It's about recognizing what that triangle means for solving something unknown. So for instance, on the lesson plan for tonight, one of the triangles that we talked that we're going to be talking about is a scalene triangle. Now a scalene triangle is a triangle that has 3 unequal sides. So this side here might be 1 unit long, this might be 2 units long, and this might be 3 units long. Okay, so now we're talking about triangles, we're not talking about angles, right? Now the angles are relative to it, right? Each one of the angles in here will be relative to the fact that the length of the sides are all different. Okay, and if you look back at the lesson plan from 3 weeks ago, you'll quickly be able to start identifying how angles relate directly to the triangles that we're talking about. So this one here, this is your, I'm going to just crank down my pen here. So this is our scalene. Okay, the other one, now this one's very important when it comes to having to solve math equations. So, because I can't draw perfectly, forgive me, but isosceles, the isosceles triangle, as you saw in our lesson plan for tonight, the length of this side and the length of this side are the same. So 2 sides in an isosceles triangle are the same. That means that the base angles, okay, here and here, so these angles in here and here, they are also the same. This is our base of our isosceles triangle. So the base is the side that is a different length from the other 2. This length here is called the leg, and this length here is called the leg. Okay, so if you forget, this is the man's legs, and he's standing on the ground, right? I know it's horrible, but whatever helps you remember. Okay. All right, so that's the base. These are your base angles. Those two angles are the same. These two lengths are the same. Now, how that helps us is if we get into a situation where we're trying to solve an angle on the inside of a triangle, and maybe I tell you that the angle up here is 10 degrees, and then I say solve angle B. So all I tell you is that this angle is 10 degrees, and I want you to solve angle B. That's all the information you need, because what you know is that this angle and this angle are the same. So you need one more piece of information. So at the end of our lesson plan for tonight, you'll see at the bottom of that principle 6. Okay, principle 6 says that the sum of the angles of any triangle is 180 degrees. So I told you at the beginning of this course that sometimes in my classes, when I teach in front of a classroom, I say to the students, you may want to remember this, or you may want to write this down. The reason I say that is because it's a key component. It's an important piece, and that you'll probably be tested on it. So I'm going to tell you that tonight, and a couple of things. For instance, principle 6. Okay, this is something key. This is something you want to make note of. Any triangle, doesn't matter if it's a scalene triangle, doesn't matter if it's an isosceles, it doesn't matter if it's a right angle triangle, it doesn't matter if it's an equilateral triangle. Any triangle has 180 degrees. If you remember that, and you can identify a triangle when solving unknown angles, you're 95% the way there. Okay, so with a little bit of practice, you start seeing information on a triangle before you even read the instructions. Okay, so if I know there's 180 degrees in this triangle, and I know that this angle is 10 degrees, then I know that 180 minus 10 is 170, and I want you to solve B, and that B is equal to A. So 170 divided by 2, right? So 170 divided by 2 is 85 degrees. So that you can see having these key pieces of information just make it so much simpler. Okay, this would not apply if I just labeled this B. You know that any triangle is 180 degrees, and I want you to identify angle B, and this is 10 degrees. You still don't have enough information, right? It's only because this is an isosceles triangle, knowing that this length and this length are the same, and that this angle and this angle are the same. Okay. All right.
Cool. Hey Adam, are you recording today?
Yes. Yeah. Every lesson I'll record and post the next morning.
Okay, I wasn't sure. On Teams it tells us like if it's recording. I wasn't sure because I didn't see anything.
Yeah.
So
So I don't use Microsoft Teams. I use Zoom. So
okay.
and I don't record through Zoom because I was having difficulties. 2 of my classes
Oh,
didn't record, and I had to do it without a class. I had to redo it and post it. So I have some new software now, so I'm actually screen capturing the whole thing, video recording.
right on.
Okay,
Thank you.
no problem. All right, let's move over to the next triangle. So we've talked about a scalene, we've talked about isosceles, and then of course we can't forget about our equilateral triangle. So our equilateral triangle is just as it sounds. Okay, other than my drawing being absolutely wretched. An equilateral triangle, all 3 sides are the same length. That means that all 3 angles are the same size. So what do we know about an equilateral triangle? Equilateral. Okay, so what do we know? Well, we know that any triangle, every triangle is 180 degrees. So if I want to solve anything about this triangle, if I want you, let's call this triangle ABC, and I say that x equals 10 units, and that's all I'm going to tell you. So let's say if I give you this, x equals 10 units, then you know that this x also equals 10 units, and this x equals 10 units, because this equilateral triangle means it's equal. All the sides are equal, all the angles are equal. Okay. A, B, and C. Do I need to tell you anything about the angles? Well, no, because I know that in any triangle, the angles, the sum of the angles is 180 degrees. So if I divide the triangle by 3, I get 60 degrees. So here's an interesting rule. With an equilateral triangle, the angles are always 60 degrees. Never changes, okay? Obviously, if there's only 180 degrees in a triangle and all the angles are the same, they can only ever be 60. So that's another key thing to remember when you're trying to solve unknown information in a triangle. Identify, what kind of triangle is this? Oh, it's an equilateral. That tells me so much, right? So start there. What triangle is it? And then what's the angle that I'm looking for? Everybody should be familiar with, of course, the right angle triangle. Now, I want to just make special note here, okay, so that there's no confusion. Right angle triangle has this, really it's a square in the corner, but you understand. A right angle triangle has this right angle symbol in the corner, right? Now, if I were to draw the exact same triangle, if it was possible, because I'm not an artist, but if I was able to draw the exact same triangle, but let's just do it a little clearer. Okay, approximately, okay, other than that little arc. Same triangle, okay, if I said to you, this triangle and this triangle, they're the same. But I don't put a right angle in this corner. Then this triangle, depending on the length of this side, and the length of this side, and the length of this side, this could in fact just be a scalene triangle. And really, if the side of this right angle triangle, if this is 2 units high, this is 2.5 units long, and this is 4 units long, this is a scalene triangle, except if it has the right angle symbol. Okay, so even if this is 90 degrees, okay, even if it's 90 degrees, if it's not shown, we don't assume it's a right angle triangle. Okay, so you have to look for this. Even if you do the math on this, let's say I gave you enough information that you could solve the 3 angles, even if this angle here works out to be 90 degrees, that doesn't matter. Unless I tell you, or unless you see it marked, identified as a right angle, then you don't treat it like a right angle. Okay, so this is the difference. Doesn't matter if these sides are all different lengths, and it doesn't matter if these 3 angles are different angles. If it has this symbol, it is a right angle. Okay, a right angle triangle. So just keep that in mind. Right angle symbol overrules it being any other type of triangle. Okay. All right. Let's go to, is it 4? Good. All right, so we're going to just do quickly, we're going to do a couple of examples together and how to solve unknown information with these, being able to identify these different triangles. All right, I just want to see if I can pick something that's at least a little bit challenging here. Okay, let's do this one here. All right, so let's take this triangle. Oops. I'll try and make this a little bit bigger so everybody can see. All right. And then we'll go here. Actually, you know what I'll do is I'll get rid of that, and I'll do it this way. Okay. I'm going to call this angle 3. Okay, and I'm going to call this here. We're going to call this angle 2, and then we're going to call this angle 1. Okay, so angle 1 is here, angle 2 is here, and angle 3 is here. And we're going to call this here 50 degrees. Okay. All right, so we've got 3 angles that have no dimensions. We have 1 angle that is clearly dimensioned. So let's say if angle 1 equals 26 degrees, and feel free to work this out, guys. I'm going to give you a couple of minutes because I want you to try and do some of this work yourself, so I'm sure that you got it. If angle 1 is 26 degrees and angle 3 is 48 degrees, good, then find angle 2. Okay, so we'll do this one together, and then I'm going to change it up, and I'm going to have you do the next one, and then I'll get your answers. So what are we looking for then now is kind of the key, right? What information do we have, and what are we looking for? So what I'm going to do is I'm going to put in the information that I need for the time being. So this angle in here, angle 1, is 26. Wow, all these markers are so huge. Okay, so let's say 26 degrees, and angle 3 is 48 degrees. Okay, so I know this angle and I know this angle. So this is what we're looking for. So the angle here in this corner is for this triangle. So the first thing I identify is that there aren't just 1, 2 triangles, there's 3 triangles, right? So look for that, watch for that, right? We're dealing with 3 triangles here. So I have an angle for this large triangle. I have this angle and I have this angle. So if I didn't identify right at the beginning that this large triangle was there, I couldn't solve this, right? But what I know is that that large triangle is 180 degrees, right? All triangles are. So the large triangle is 180 degrees. If I subtract 26 and then I subtract 50, then that will give me this angle right here, right? So 180 minus 50 minus 26 is 104 degrees. So this angle on the inside of this large triangle is 104 degrees. Okay, well, how does that help us? Well, now what we know is this angle here and this angle here. So that will allow us to solve this angle here, angle 2, right? So I know that angle 2 is 180 degrees minus 48 minus 104, right? So 180 minus 48 minus 104. So I know that angle 2 equals 28 degrees. Okay?
Adam,
Yes.
I'm a little confused.
No problem.
So angle one is 26 degrees. The angle one spans across
Two
both.
triangles.
Right,
Right.
right. So
this is, let's call this triangle number 1.
okay,
Okay? Let's call this triangle number 1. So the very first thing, I know that there's 3 different triangles here, right? I'm going to put this line here. Actually, you know what? We don't even need that. I know that there's this triangle. I know that there's this triangle. And now I also know there's this triangle. So the key to solving this is to identify there's a third triangle. That's the first step, right? Because if we don't identify that, then here's our problem. Let's say we want to just solve angle 2. Well, angle 1 is here. I don't know, like this angle here and this angle here may not be the same. We can't assume that they are. I know that this full angle, this full angle right here is 26 degrees. But what I don't know, I don't know what this angle is. That's the one I'm trying to solve here, right? That, it doesn't matter where you put the arrow. It's this angle in here, which is part of this triangle, right? And then we have our third triangle, which is in here. So yes, it can be a little confusing at first, but the key here is to first see how many triangles do I have, right? It looks right away like 2, one here, one here. But when you combine them, they are in fact one big triangle as well. So let's do something here. I'm gonna just make your life a little easier, and we're gonna get rid of all this wonder. Okay. And we're gonna let's just draw the one triangle here. That's triangle number 1. Okay. At triangle number 2, I'm just gonna draw with its own color. Okay, is here. Here's triangle 2. And the whole thing, right? So the black is one triangle, and the red is, we'll just share a line here, right? The red is a second triangle, and then on the outside, if I can stay away from this line, I'll just draw around it so you can see it. So this line is just demonstrating that what's inside of it is another whole triangle, right? So there are 3 triangles here. And the key, the thing that we want to remember is the information that's given to us. If I say this is angle 1, it is in fact spanning these 2 triangles, but they are one big triangle as well. And the other information that I have an angle down here on this red triangle, but where's angle? I forget. Angle 1 is there. Angle 2. So I want to know what the angle here is. When I'm all done, this is the angle I'm looking for right here. It's part of angle 1, but you can see it's its own angle. And angle 3 is here, right? So angle 3, we know in the black triangle, is 48 degrees. right? And angle 1, which is this whole angle here, we just draw the line on the outside, is 26 degrees. Okay. So if look at just the colors, I know that this angle is for the big triangle. And this, even though this is in the red triangle, this is in the small triangle, this is actually the corner of the big triangle, right? This big triangle is just this. That's that big triangle. This is 50 degrees. This is angle 1, right? And we're not drawing in angle 2. But this is angle 1 here, and I've said angle 1 is 26 degrees. So in the big triangle, this is 26 degrees. So I know that this large triangle, right, this big blue triangle, it is a total of 180 degrees. So if I subtract the 50 and I subtract the 26, right, it's going to give me, what was it, 100 and, where are we here? 180 minus 50. Oh, I didn't write it down, did I? 180 minus 50 minus 26. Oh yeah, it was 104, right? So equals 104 degrees. That's that large triangle. The reason we have to solve that is because we need this angle, that 104. That 104, see this, even though this is the corner of the big blue triangle, it's also the corner or the angle of the black triangle. Right? So this angle is still 104. The degrees is still 104. Even if the triangle ended right there, that's still a 104 degree angle, right? That the angle doesn't change. So now what we have is this black triangle, right? And this black triangle just looks like this. And we have 48, and we have 104, and we need angle 2, which is this right here. And that's what we got up here. 180 minus 48 minus 104 gave us 28 degrees. Geometry is one of those types of math where it doesn't just make sense to everyone. You need to look a little bit. And as we go further in this and we start looking for, we start solving trigonometry problems, trigonometric problems, then we need to understand angles and we need to understand triangles, because what we're learning here is, what am I looking for? Some questions can get very, very confusing. And if we don't know what we're looking for, then we just remain confused, right? And sometimes we're given more information than what we need. So identify the information that we need for the question. And that's honestly, it's like anything else. It just comes with practice. I know the last thing you want to do is, after a long day of work or school, sit in front of sit at the dining room table and work on math just for the fun of it. I love math. I love solving problems, but not everybody does. So it may take a little bit of practice for you to figure this out. Let's just go back to a couple of maybe a little bit simpler triangles to see if we can solve some easier problems. Let's take this one for instance. All right, so this is, we're going to call this angle EF, our triangle EFG, okay? And the length of this side is 13.5 units long, and the length of this side, whoops, the length of this side is 13.5 units long. Okay. If angle E equals 81 degrees, find angle G. All right. What do you think? I'm saying angle E is 81 degrees. What is angle G? If you know, speak up. If you don't, keep quiet.
Would you use the sine law to figure it out?
Nope. Just strictly identifying triangles. So the key thing would be, and I appreciate you saying that, Miles. The key thing would be is identify what kind of triangle is this. Can you tell by what I've drawn here what kind of triangle this is?
Yeah, this is an isosceles triangle.
Right. It's isosceles because the length of this leg and the length of this leg, right? GF and EF are the same lengths. If they are, then you know that the base angles also have to be the same. So step one, identify the triangle.
Mm-hmm.
As soon as you know it, then you can figure out what's missing. Because otherwise, if you didn't know this was an isosceles triangle, this doesn't help you. You know there's 180 degrees in a triangle, but if you only have one angle, how do you know what the other two are? But if you know it's an isosceles triangle, then this is 81 degrees. You know that the other base angle is also 81 degrees. Now, what if I didn't give you the base angle? What if what I said was if angle, let's say angle F equals 81 degrees. Can we solve it now?
You would subtract 81 from 180 and then divide by 2, correct?
Yes, that's exactly it. So 180 minus 81, right, is 99. Divide by 2, which is going to be 44.5, right? Oh, 44.5 degrees. So identify the triangle. Okay, that is number one, and that will help you. And so you'll notice that the lesson plan that I gave you guys for tonight, it's not very long and it's not in depth, but I spent some time making sure that the 4 triangles are very well explained. And the reason for that is I want you to be able to take out that lesson plan when you're doing your homework and look at the triangles and what makes them what they are. Does that triangle look anything like the triangle in my question? This one does. Okay, so what do I know about this triangle? That's how you solve this. That when you're starting with geometry, that's how you solve this. Okay, is identify the triangle. Yeah, it's good work, you guys. So let's see if we can throw you a tiny, tiny curveball. Don't worry, it won't kill you. It'll be fun. All right. So here's our little curveball here. I'm gonna draw this triangle. I'm gonna try and do this a little more true. Okay. All right. The length of this side is 3.4 units. The length of this side is 3.4 units. This angle in here is angle 3, and this angle in here is angle 2. All right. If I said what does angle 3 equal and what does angle 4 equal? Look at this triangle and identify what kind of triangle it is. What do you think?
Am I allowed to answer, or should I let someone else?
No, no, speak up.
Okay. It's an isosceles triangle. So you would take 180, subtract 90 because the other angle is a 90-degree angle, and then divide by 2.
Good. So everything that you said is right, except at the very beginning. Is it an isosceles triangle? It is an isosceles triangle, but when it has this symbol, it is a right angle triangle. Your math is still right. No, and don't, Miles, don't make that afraid, make you afraid to speak up. You're right. The math works. How you solve it is the same. But if I asked you what kind of triangle is this, and then asked for the two angles, the right angle triangle takes precedence. Okay, so just keep that in mind. Does it really matter? It would if we had some missing information. Angle 4. Let's make this angle 2, shall we? Angle 2. It would matter if we were missing some information. Like, for instance, if I wasn't asking for angle 2, and we didn't have the length of the side, or we had angle 2, but we didn't have the length of this side. The math will still work, but being able to identify the triangle is also important. So if you heard what Miles said, she's absolutely right in how to solve it, but just make sure you look for this symbol, okay, when identifying triangles. Good. No, that's awesome. Okay.
Can I just ask a question?
Yeah, 100%.
Okay, so it is a right triangle. However, just like Miles pointed out, so we've got two equal sides.
Yep.
Therefore, two equal angles.
Correct.
So
Yes.
so angle 3 equals angle 2 because of those two equal sides, so that they each equal 3.4.
You
Is
got
that
it.
correct?
You got it. So
Okay.
even though, and this is why I said it's a bit of a trick question, because the way Miles explained it is dead on. Okay, there's nothing wrong with that at all. An isosceles triangle is identified by its two legs being the same length, and then its base angles will be the same, regardless of what this angle is. Okay, at the top. The difference is that if we don't identify this, or even if we do identify this, it doesn't have a bearing on solving the triangle. All it has a bearing on is identifying the triangle. That's it. Right? So because this is 3.4 long and this is 3.4 long, whether this is a right angle or not does not change the fact that these angles have to be the same. Have to be. Right? So this will be 180 minus, or sorry, minus 90. Come on. Oh, something's wrong with my pen.
Yeah. 180 minus 90.
Yeah.
Like minus that right angle, 90.
Yep.
And then the product of that, or the the answer for that, divided by 2, because angle 3 and angle 4, or angle 3 and angle 2 are equal.
You got it. Yeah.
45 degrees.
So don't let the description of the triangle confuse you. Identify the triangle first, but then look for the information. What am I looking for? What am I trying to solve? Right? So good. There's one more question I want to do with you guys, and then we'll wrap up the instruction part of this, and I'll open up for some questions. So where is it here? Okay, this one here. Okay. Now you're gonna have to just give me a couple of quick seconds here, and I'm just gonna write out the instructions. Whole center lines AB are parallel to CD. So this is going to bring us back. It's going to kind of tie in our lesson from 3 weeks ago. And I'm just going to say if angle 1 equals let's just say 86 degrees. Find angle 2, and if angle 2 equals 67 degrees, find angle 1. Okay, so let's go 1, and we're going to draw our line here, and we're going to draw our line here. Okay, so this is line AB, and this is line CD. Okay, and you know what, maybe, let's see, we'll do this here. I'll draw our next line. Oops, that's no good. We'll draw our next line here. And we're going to say that this is 23 degrees in here. Okay, so that's 23-degree angle. This here is angle 1. Actually, I might as well just write the angle in for you. Okay, this is angle 1. So angle 1 is 86. Okay, what we're looking for is this angle right here. Okay, so here's the thing. This brings in a little bit of the lesson from 3 weeks ago. What we have and what we need to know is that line AB and line CD are parallel. If these lines are not identified in the instructions as being parallel, then they are not parallel, or at least you can't assume that they are. Okay, so don't assume that this line here and this line here are parallel, okay, because they are not. But I've called out at the beginning that AB is parallel to CD. So how does that help us? Well, it helps us because what we can solve is, or what we can do is look for information that's true in the or looking back at the first 5 principles of geometry. Remember this principle here, where when you have 2 parallel lines and they're intersected by a transversal, that this angle and this angle and this angle and this angle are all the same, right? Because if I take this line, because it's parallel to this one, if I pick it up and drop it on top of this, they will be in the exact same place, right? So therefore, this angle and this angle would have to be the same as these 2 angles. And that means that this angle and this angle, this angle and this angle are also all the same. So I want to look back at this and see, does this apply? It does apply, because I've said that line AB and line CD are parallel, and they are intersected by a transversal. So what does that tell me? It tells me that this angle and this angle are the same, right? Remember, this line and this line, this line and this line are not parallel. So the only angles we can use are angles that follow the rules. AB and CD are parallel. So this transversal intersects this parallel line and creates this angle here. This transversal, if you follow it the other way, intersects this parallel line and intersects here. So this angle and this angle have to be the same. They have to be, okay? Notice that in this example up here that this angle right here is this angle right here. So jump on the transversal, follow it up, jump on the transversal, follow it up, and that angle is that angle. So this is true. But any intersection with this line or this line we can't use because we don't know anything about those lines.
Sorry to interrupt, Adam.
Yep.
You're saying this line and that line. The lines that you're making reference to, I can't clearly tell. If you're using a pointer,
yeah, sorry.
I'm not able to see.
Okay, so this blue line that I'm drawing.
Yes, thank you.
And this blue line, okay, we don't know anything about them at all, zero. So we make no assumptions. We don't know what they are. We don't know if they're parallel. We don't know anything. So we don't do anything with them. What we're looking for is to apply principles that we can use because we have the right information. So because A, B, and C, D are parallel, and they are intersected by one transversal, right, a transversal line, then we can accumulate information where that transversal and those parallel lines intersect. So that parallel line here intersects with the transversal here. So we can use this angle. This transversal continues up to the next parallel line, which means that this angle is the same as this angle. So I'm going to write that in here, that this is 23 degrees in here. So what I'm asking for is this angle, which is angle 2. Well, now we can solve it, right? Because now 180 degrees minus the 23 degrees we just solved minus 86 degrees, 180 minus 23 minus 86 is 71 degrees. So I know that angle 2 right here is 71 degrees. So I don't want this lesson to go past this. I want to make sure that you can tie in what you learned from 3 weeks ago. Those principles, they're not overly complicated in themselves, but when you're looking to solve math problems in geometry, you need to be able to identify principles, or at least be able to look at a problem and say, okay, somewhere in here is a principle that I need to use. I'm going to look back at my list of principles and see which one applies. And you will have to do that for some time until you get used to this. But like anything else, soon you start seeing things and identifying things real quick. You start seeing angles and triangles quickly, and you know what you're looking for. So